Hello everyone, this is the second part of lecture 2 and I'm going to loosely follow the slides for chapter 2. I'm not going to show you all of them. We need to talk a little bit about character strings and then variables, primitive data types, expressions, and maybe touch upon data conversion. Okay. So here is my previous project. If I want to close my project, I do this. And then I'm ready to start my other project. And let's call it lecture 2B. New project. And I'm just doing this so that you are more used to... Oh, sorry. My bad. So I was searching instead of creating a new one. I did not need to do that. I just click on new project. Here is the name, lecture 2B. And, well, check that everything is okay. Java, Amazon Corretto. And here we go. So the project was created. Then I go to the source folder. And I'm creating an actual class. New Java class. I'm gonna call it main. Again, it is a given name. And since I don't want to be typing up trivial stuff, I'm going to do the acronym public static void PSVM. And here we go. We created a main. Just a quick recap. I can create strings. My string and equals to blood. And that will actually not work. I used single quotations. Single quotations are for characters, not strings. And just to make sure, strings is a class and not a primitive type. Mostly we will talk about primitive type, so I just want to emphasize that string is something else. We talked about strings in the previous video. Alright, and now on to variables and assignment of variables. I can create a variable x, which is an integer, so the little int here, it means it's an integer. It's a primitive type, and I don't need to assign it to any value. However, system.out.println x will cause an error. And the reason for an error, the variable was not initialized, it was just declared. And IntelliJ is smart enough to tell you that without running the code. If you run the code, you will get about the same issue. And that's how you can run the code for the first time if you insist on doing that. Okay, where is my error message? It's still running. We're waiting. It's still running. Didn't I click on it? No, it's running. It should be about done running. Don't know why it takes so long today. Yep. Variable was not initialized. That's the issue. And if you hover over, they will tell you the issue here, and it will pop up. Okay, so I need to initialize it, and I'm going to initialize it as 5. And just to have another type declared, double is a default type for real numbers. There is float, let me say 2.3, but a float takes less space, but it's not default, so some of the routines could be optimized for double. So generally, unless you are super concerned with space, use double, I guess. And how about we do some mathematical operation between them? Z equals to x plus y, and z is suddenly red. And if I hover over it, it's gonna tell me what's wrong. Cannot resolve symbol z. Before I'm using a new variable, I need to define its type. And again, it's a primitive type double. I have to because my y was of that type. And how about I just print x plus empty string plus z. Of course, what will this do? This will print both numbers, but without any blank space in between them, so I better off do that. Yeah, it will look like one is concatenated with another. So 5 plus 2.3, that is my value z, 7.3. And there was 5, that one's 7.3. Now I will have my comma and blank space in between, so it will be more clear. Alright, so that was one thing about variables. There is also booleans. So we will talk about boolean a little later. I'm gonna call it bool just for fun and say that it is true. So we can also declare boolean variables, and as you can guess, they will make more sense and be more important when I will have some decision structures like if else or an alternative decision structure switch. Okay. Let us try something that we know works from Python. And I'm going to reassign my y to be equal to y plus x. So maybe I'm going to remind you how to do this. I'm not going to use this code anymore, so I'm going to do Ctrl plus and single slash, and now it is commented. And now I have a problem with the z variable. I'm just going to delete it. And for clarity, I'm going to say the x value is x and the y value is y. Okay, so what I did, I decided that y will be the old y plus x. So this is a reassignment operation. Now what I'm missing here, and IntelliJ will immediately tell you that, I'm missing the semicolon. In the end of every printing statement, there should be a semicolon. Alright, let's run and see that it does what we expect it to do. So now my y will be 5.3. Is 5, the y value is 7.3. Okay, I may want to have a blank space over here and say semicolon. Okay, that's what we wanted. Now, curiously, how about I do the other thing? I'm going to spoil my variables now. X, let me comment this out. X will be equal to x plus y. And what does it not like it about this? Cast to int, yes. So I was trying to add an integer and a double and make it an integer. And of course it's not very happy about that because x is supposed to be an integer. The Java is enforcing the types. If I declared my x to be an integer, it should be an integer throughout the computation. And think of it as a safeguard against errors. So I cannot quite do that without casting. And I did not do the casting yet, so I'm just not going to do that. So what if I like a float? float z equals to y. Well, y was a double. Double is like an extended float, and if I want to cast it, my casting will go like this. So in parentheses float will make my y from double to be a float. So that way things will work. And I commented out all the addition or reassignment operations, so it's gonna be original values after it's done running. So I'm back to my original assignments. I can also do z equals 2 and plus z, since I'm breeding variables like flies. So this is how you do casting. Now, casting may cause an issue, and that is, what if I'm casting to my int type instead? Int z, and I'm going to cast my y as an integer. So we are coercing y to be an integer now. This will work, however, this will lose information. So z is now equal to 2 because I casted the number 2.3 as an integer, and just for fun, let's reassign it 2.7, same thing, and see how it will cast 2.7. So this is something to be aware of and to know how to lose information. So it does not round. Y was 2.7. It just cuts off the fraction part, the decimal part. Okay. So there is more primitive types. So far I have showed you integer, double, boolean, and float. And there is 4 more. Altogether there is 8 primitive types, and we will need to know them. Oh, at least know that they exist. Not all of them are appearing equally frequently. So where is my primitive types? So 4 of them represent integers: byte, short, int, and long. Long is extended integers, excuse me, and I will show you the range for them later. Byte is very small integers, and short is somewhere in between. And the difference between them, they reserve different amount of memory to store numbers. So if your numbers is 1 through 10, byte is a way to go. It will save you some space. I mean, if you are going to use those numbers on industrial scale. And correspondingly, you can save yourself some memory by using short if you have to. Now, 2 for floating point numbers, in other words, real numbers. Double is default, and float is kind of for saving a little memory, although some routines may run longer. Char represents single characters, and finally there is booleans. And I cannot emphasize this enough, string is not a primitive type, it is actually a class. If that still makes you feel insecure, what is a class, that's fine. We are going to talk about them in Java and in advanced Java. So here is the sizes in bits. Byte is literally 1 byte, which is equal to 8 bits, and that is 2 to the power 8, and hence it can hold only 256 different values, so from -28 to 127. Correspondingly, this is 2 bytes, 16 bits, and the long is 64 bits, that is 8 bytes. So kind of use int if and be comfortable unless you know you're gonna deal with something long or you want to save space. Float and doubles, here they are, and the way they store data is a little bit tricky, but we are not going to go into that. Now, characters are for single characters. Notice the single quotes. The single quotes and double quotes in Java are not interchangeable. Single quotes are for characters, double quotes are for strings. And I think jar holds any Unicode character. And you can discuss a little bit more about characters. We can discuss if need be. For now, I don't think there is a need for that. Finally, Boolean true false. Unlike Python, it's not capitalized. True and false are not capitalized. It's just a choice. We will play with Booleans a lot later, but for now it's good enough. So those were primitive data types, and I need to talk a little bit about the operations and how they work. And for that, I'm going to use a Word document. Yes, you heard me right. I'm gonna start an empty document. Where is Word? I don't know. Bear with me for a second. I want to remind you how to do division of integers. For example, I want to divide 23 by 3. I'm going to ask myself how many 3's are in 23, and I think there is 7. So 23 divided by 3, we mean integer division, is 7 because 3 times 7 is 21, and there is 2 left. And just like in Python, those 2 left is a remainder, the notation for it, remainder, and the notation for it is percent sign, so 23 over 3 equals 2. And what does this mean? Meaning that 23 is equal to 3 times 7 plus 2. And just for fun, we can do another example. 18 divided by 5, that will be, of course, that will be 3. And 18 remainder when dividing by 5, when dividing by 5, happens to be also 3. And altogether, this means that 18 is equal to 3 times 5, or in this case 5 times 3, the divisor times the quotient, plus another 3. So I'm reminding you about what was in your childhood long division, and hopefully that sounds familiar and you can actually remember the notation for long division and do long division of a couple of numbers by yourself to make sure you remember what is remainder and what is a divisor and quotient. Alright, so all is clear with plus, minus, multiply, divide. And the one that I'm worried about is integer division and integer remainder. They kind of go together. You can use them on float point values, that is double and float, or you can use them on integers or short or bytes and such. So 14 over 3 equals 4, because 4 times 3 is 12, and there is 2 remaining 2, like remainder 2. And here it is. Similarly, 8 divided by 12 is 0, because 0 times 12 is 0, and there is 8, a remainder. 12 does not fit into 8, that is why it is 0. The quotient is 0. And those are some examples, so feel free to stop and think what this means. Let me do the second one. 12.0 divided by 2.0. When we write 0.0, that means we're dealing with floats, whether it's actual float primitive type or double, the default primitive type for like real numbers. And 12.0 divided by 2.0 will give me 6.0. Whereas if I'm dividing 10 by 4 or 12 by 2, as they are shown here, this is integer division. 10 divided by 4 will give me 2. Now similarly, 10 divided by 4.0 will give me 2.5, because now that 4.0 is a floating point number, 10 divided by 4.0 is interpreted in the following way. 10 is cast as a, well, by default double, unless otherwise very specified, as the same data type, primitive data type, as 4.0. So usually when you have to convert, when the conversion is done in operation, it is converted to a more general type. That's the rule. The float would be a more general type than an integer, so 10 will be converted to a float, and then division is performed. So we can really see that the remainder of 12 divided by 3 is 0. That is because 12 divided by 3 is 4, and 3 times 4 is 12. So the remainder of 10 divided by 3 is 1, because 3 fits 3 times in 10, so 3 times 3 is 9, and there is 1 left. And 3 remainder when divided by 10 is 3. So this is an error, actually. 3 remainder 10 is 3. Okay, let's double check that. So I'm going to do system.out.println, and I'm going to say 3% 10. Let's run this. Oops, I need semicolon. Let's run this. The remainder is 3, as I was promising you, and not 0, as the handout would have it. 3 remainder 10 is 3, and 3 divided by 10 would be 0. So I guess they mixed it up. Okay. Alright, so operators can be combined into larger expressions, and then there is a issue of order of operations. So multiplication, division, and remainder are evaluated before addition, subtraction, and string concatenation. Arithmetic operations with the same precedence are evaluated from left to right, but parentheses actually work first. So a plus b plus c plus d plus e doesn't matter in which order, they are all pluses, so we will get the same result. For the second one, first I need to do product, then I need to do quotient, and then I do the corresponding pluses and minuses between them. In general, I think it's sometimes beneficial to put parentheses even when it is not completely necessary. For example, over here, c plus d minus e will give me the same result as c plus d minus e. However, in other places, over here and over here, the parentheses are very necessary, and the expression will change if you don't have them. Alright, so those are the answers of order of operations. Yeah, doesn't matter how you do this, it's addition. B times C is the first here, D divided by E is the second here, and then you do plus and minus. Well, parentheses you do first, then you are ready to do the division, A divided by the result of B plus C, and D remainder E is the third one, and finally there is negative between them. Alright, there is something that is called expression trees. We are not going to spend much time on them, but they are a great way to describe an order of operations. And also, if you present something as an expression tree, you cannot possibly go wrong. So if I was to try to perform addition first, A plus some division, oops, cannot do that. The only way I can perform operation if I look over here. So B minus C makes sense. After I did that, that was the first operation, I can do my division, the result of the previous operation divided by D. And finally, I can perform my addition between A and result of these two operations. So you kind of go in this tree from bottom up. Trees are fun. In data structures, there will be some interesting examples with trees, some interesting algorithms with trees, and all. Okay, so I need to work on assignment operations, and I'm just going to do it in my IntelliJ program. So for simplicity, let us forget about stuff other than integers. And I'm just going to delete everything except for x for now. And first of all, x plus equals 1 works. This is the same as what you had in Python. That means add 1 to the current value of x, and 6 will be printed. I'm going to do a quick run to make sure that it works. And the value of x, the x value is 6. Alright, there is another way to get the same result. X plus plus, sorry, double plus, and that will also increment by 1. That is a shorter way of adding 1. Very similarly, minus minus will subtract 1. And you can do this with prefix. So this will also perform the same, will have the same meaning. And by itself, the prefix and postfix notation, where you put pluses, basically does not matter, before or after the variable. When you use this in formulas, you have to be careful because there is an exact interpretation what it does. I don't know, the book does have an explanation, but slides probably don't. It's not something I use personally, double plus in operations, so I'm a little insecure remembering which is which, so probably not that important. Remember, you can always do the full notation. There is no shame in that. Just type a little bit more and it will be more clear for you and maybe for other people as well. So that's how you can reassign a value to increment the value by 1. Reassign it to be 1 more by 1. Same stuff. I was just saying that, and prefix and postfix form. And what we had in Python, which is equivalent to num equals to num plus count. So we are incrementing by whatever is the value of count. Here is our augmented notation operations, as they were called in Python, and they are exactly the same. So this is exactly the same as what you have seen in Python. Let's think a little bit about what this means. Unfortunately, we have the answer right away on the same page, but the order of operations is the following. The right side is going to be computed, and then the result is going to be divided by the right side and reassigned to be a result. So pause, think through that. This is something that we may be doing sooner or later, and you might want to be comfortable with that. If you recall your Python class, you know that usually we do this augmented operations inside a loop, so they are repeatedly, so result would be repeatedly changing on every iteration, for example. And well, I did talk a little bit about the data conversion, so we can narrow and use short instead of int. We can either explicitly cast or we can promote to a more general type. So there are widening conversions that don't lose information. Let's say byte, that is the smallest range for integers, can be promoted to, can be converted to anything. Short can be converted, widening to almost anything except for byte. And chars can be converted to int, long, float, or double, provided the char is actually like a number, but in the character form, in the character type. And there are some narrowing conversions that do the opposite, and we will talk about converting chars to byte in due time. So int dollars is 20, double money equal dollars. That will be that will work. So they can happen by assignment. You don't need to specifically convert. So dollars was an integer, but since we said double money equals to dollars, the value of money will be 20.0. And in general, I would need, for this to work, I would need to the result to be a double. So count was an integer, sum was a double, the quotient between them will be a double. Alright, so we have seen that, and we did not in this lecture do too many examples, so I guess I will stop my video here.